Hello everyone. Now we are starting the next part of Introduction to Network Layer Unit 4. So next topic is Unicast Routing. In Unicast Routing, there is one-to-one relation between the source and the destination. That means only one source sends a packet to the only one destination. This type of source and destination addresses included in the IP datagram are unicast address to assign to the host. The concept of the unicast routing is shown in the figure. In unicast routing, when a router receives a packet, it forwards that packet through only one of its ports, which corresponds to the optimum path. The router can discard the packet if it cannot find the destination address. A metric in the unicast routing is defined as the cost assigned for the passing through a network. The metric is assigned to the each network depend on the type of protocol that is used in the routing. Interior and exterior routing. As an internet is a large that for one routing protocol, it is impossible to handle the task of updating the routing table for all routers. So internet is divided into number of autonomous systems. An autonomous system is a group of networks and routers. Interior routing, the routing that takes place inside an AS, that is autonomous system, is called as a interior routing. And exterior routing, the routing that takes place among the various autonomous system, is called as a exterior routing. Next is broadcast routing. In the certain applications, the host has to send the packet to many or all other hosts. If the sender sends a packet to all destinations simultaneously, then it is called as a broadcasting. The various methods of broadcasting are simple broadcasting, flooding, and multi-destination routing. So, simple broadcasting. In this method, the source will simply send a separate packet to each destination. This method has two drawbacks. First is a lot of bandwidth is wasted, and second is the source has to have the complete list of destination. Next is flooding. Flooding is the another method used for the broadcasting. The problem with the flooding is that it has point-to-point routing algorithm, so it consumes a lot of bandwidth and generate too many packets. Next is multi-destination routing. This is the third algorithm used for the broadcasting. In this algorithm, each packet will contain a list of destinations or a bitmap which indicates the desired destination. When such packets arrive at the router first checks all destinations, then it is decided to set up output lines that will be required based on the destination address. The router then generates a new copy of the received packet for each output line to be used. It includes a list of only those destinations that are to use the line in each packet going out on that line. This will save a bandwidth to a great extent. Also, a generation of too many packets right from the sending end will also be avoided. Next is multicast routing. In multicasting, a message from a sender is to be sent to a group of the destination, but not all destinations in the network. A process has to send a message to all other processes in the group. For a small group, it is possible to send a point-to-point message, but this is expensive if a group is large. So we have to send the message to a well-defined group which are small and compared to the network size. Sending a message to such a group is called as a multicasting, and the routing algorithm used for the multicasting is multicast routing. The multicast routing is the special class of the broadcast routing. Next is routing algorithms. One of the important functions of the network layer is the route the packet from the source machine to the destination machine. Routing algorithm is a part of network layer software. It is responsible for deciding the output line port over which a given packet is to be sent. Such a decision is dependent on whether the subnet is virtual circuit or its datagram switching. Desired properties of routing algorithms are optimality, fairness, robustness, stability, and correctness. There are two types of routing algorithms. First is non-adaptive algorithm and second is adaptive algorithm. Non-adaptive, that are static algorithms. For these types of algorithm, the routing decision is not based on the measurement or the estimation of the current traffic and topology. However, the choice of the route is done in advance offline and it is downloaded to the router. So the choice of the routing cannot be changed in the event of congestion or link failure. This is called as a static routing or non-adaptive routing. Next is adaptive routing, that is dynamic algorithms. For these algorithms, the routing decision can be changed dynamically if there are changes in the topology or the traffic. This is called as a dynamic routing. In the following sections, we are going to discuss the various static and dynamic algorithms. So first are static algorithms. There are many static algorithms, but we are going in detail with three algorithms. First is shortest path routing. This algorithm is based on the simplest and most widely used principle. Here a graph of subnet is prepared. Here a graph of subnet is prepared in which each node represents either host or the router of each R represents a communication link. So as to choose the path between any two routers, the algorithm simply finds the shortest path between them. How to decide the shortest path then? One way of measuring the path length is the number of hops. Another way is the geographical distance in kilometers. Some other metrics are also possible. For example, we can label each arc or each link with the mean queuing and transmission delay, obtain the shortest path as the fastest path. Label on the arcs. The label on the arcs can be computed as the function of distance, bandwidth, average traffic, mean queue length, cost of communication, and measured delay. The algorithm compares various parameters and calculates the shortest path on the basis of one or combination of criterion stated above. The various shortest path algorithms are, many algorithms are there. One of them is Dijkstra's algorithm that you have studied in your FY. The other one is Bellman-Ford algorithm. Next is flooding. This is the another static algorithm. In this algorithm, every incoming packet is sent out on every outgoing line except the line on which it has arrived. That is why the name flooding. Each line except the incoming lines are flooded with the copies of same packet. One disadvantage of flooding is that it generates a large number of duplicate packets. In fact, it produces an infinite number of duplicate packets unless we somehow stop the process. There are various dumping techniques such as use and hop counter to keep the track of which packets have been flooded and selective flooding. To prevent the endless copies of packets circulating very long time through the network, a hop count may be used to suppress onwards transmission of packet after a number of hops which exceeds the network diameter. The other problem is that destination must be prepared to receive the multiple copies of an incoming packet. Flooding has two interesting characteristics that arise from the fact that are possible routes tried. First is, as long as there is route from source to destination, the packet will be definitely delivered to the destination. One copy of the packet will reach the destination via quickly possible route. Selective flooding. This is a slightly more practical than other types of flooding principle. In this algorithm, every incoming packet is not sent out for every output line. Instead of packet is sent only on those lines which are likely to go in desired direction. Applications of flooding. Flooding does not have many practical applications, but it is useful in military